Yeah, cams on your own. Let's start off. So last class we have done with the parallelogram law of vectors. So what is parallelogram vector? So this was the main thing there. So if I give you two vectors, a bar and b bar at an angle theta between them, others do keep your cams on. So if you have two vectors, a bar and b bar, and the angle between them is theta, the resultant is a plus b bar, which is this guy. This is how we get the magnitude of that resultant vector. Clear? That's what we did last time. So let's go ahead with a few more questions on this. Let's say mod a bar is equal to 2, mod b bar is equal to 3, mod c bar is equal to 4. And it is given c bar is the resultant of a bar plus b bar is c bar. Find angle between a bar and b bar. Find angle between b bar and c bar. Let's get this. Others do keep your cams on. Right one, yeah. Others, everyone should get this. You got an answer, leave it here in the chat box. You can leave in terms of cos theta. You don't get any standard angles. Let's see. If this is your a bar, this is your b bar, right? And the angle between them is theta. So when you add these two, one thing is clear, the resultant will be somewhere in the middle. This was your c bar. This angle was alpha and this angle was beta. So first thing, the resultant C square is a square plus b square plus 2ab cos theta. So this would give you the angle between the vectors. C is 4 square, 16. This is 4, b square is 9 plus 2 into 3 into cos theta. This guy will be cos theta 12 minus 1, 3, 1 by 4. That was easy. And if you got cos theta, from here I can get sin theta, which is root over 1 minus cos square theta. That turns out to be root 15 by 4. 1 minus 1 by 16. Now, I didn't ask you for alpha, but if I want to find tan alpha, what was the formula? B sin theta by a plus b cos theta. The tan beta, that is the angle between b and c. That's what we want to find. So b becomes a sin theta, a becomes b there, and this is the formula there. You can substitute here. A ka value is 2, sin theta is root 15 by 4 by b is 3 plus 2, cos theta is 1 by 4. This will be root 15, 3 plus half. 3 plus half, that is 7, 7 by 2, root 15 by 7. This is your tan beta, everyone, where beta is the angle between b bar and c bar. So using formulas, you'll get this thing. But let's say by chance you don't remember these things, like happens. People generally don't remember these angles. And there are two ways to do this. One, you can take components and finish it off. That would be faster. But everyone have a look at this page. Any doubts on this page? If your cams are not on, you'll be removed from the classroom. So do keep your cams on. So in case you don't remember this, another way to do this, I already know theta from here. So I'll just take b bar here. This is some a bar. This is angle theta. So I can resolve this into components, which will be b plus a cos theta. So basically I'm deriving the formula again, and this will be a sin theta. So the resultant of these two was c bar and this angle was beta. This is how we derived it actually. So tan beta will be opposite side, a sin theta by adjacent side. In case you forgot the formula, you can derive this. But there is another better way. So we know the alternate thing. A bar plus b bar is c bar. So you want to find the angle between b and c. So keep a on one side, and this will be c bar minus b bar is equal to a bar. Can I say like this? So then I'm going to write this thing like c bar plus minus b bar is equal to a bar. Now, doesn't this look like a parallelogram law? Sum of two vectors is the third vector. So from this formula, what do we get? So mod of c minus b, this will be mod of c plus minus b bar ka magnitude. This is your mod a bar. So this will be c square minus b ka whole square plus 2c minus b. This is the angle between them. Cos beta is equal to a square. Is that making sense? This is faster. And then what is c ka value? C is 4, b is 3, 2, 3 minus 4 cos beta is equal to a square is 4. How much is this? Cos beta will be 25, 21, 7 by 8. So this thing doesn't look like the previous one. That is because you found tan here and this is cos. How to get cos from tan? Make a right angle triangle. Cos beta, adjacent side 7 by hypotenuse 8. So this will be Pythagoras theorem, 64 minus 49, 15. So tan beta is root 15 by 7. Make sense? So if you use this method, you'll get cos beta. If you use this formula, you'll get tan beta. Yeah, both are interchangeable. This is a much faster method in case, because I have a problem remembering this. I don't remember this properly. I have to derive the whole thing. Better I can do this. I can rearrange these terms to make it like a new parallelogram law. If you add C bar and minus B bar, you will get A bar. And the angle between C bar and B bar is beta. Finish it off. Is this clear, everyone? Any doubts on this? Clear, na, Sudesh? Trishi? Clear with this? Advai?
Yes, sir.
Clear? Shlok? Sudiksha? Obia? Got this? Next one? Let's see the next one. Let's say mod A bar is equal to 2, mod B bar is equal to 3, mod C bar is equal to 6, and C bar is equal to A bar plus B bar. Find angle between A bar and B bar. So what does Max say about it? Right, Samyak, you know that, but there is a Max also should say something now. How will Max say that? Ishwan, that is wrong. Shreyansh, that is wrong. What did you get here? This is a good one. It looks innocent. Is a trap. Hmm. So you will get a number for this. But first of all, even before starting the question, can you see something is weird? Forget about solving the question. You should see something weird. A is 2, B is 3, and if you add them, I can't get more than 5. See, you can get less, huh? If you add A bar plus B bar, meaning I have two vectors, 2 and 3. The best I can do, keep 3 and 2 in one direction, I can get 5. The worst thing I can do, put 3 in opposite direction, I get 1. That means when I add A bar plus B bar ka vector, I can get any value between 5 to 1, isn't it? When you subtract them, the worst you can get is 1. And when you add them together, the max is 5. But I'm saying it is 6. So this is impossible, isn't it? So the question is wrong. So, but you and I know from seeing this, but how does Max tell that? How does Max tell you, boss, what you're asking is impossible? Let's see what Max says. Let's use a formula. C square is A square plus B square plus 2AB cos theta. You just substitute here everything. This will be 36, 4 plus 9 plus 2, 2, 3 cos theta. That guy will be cos theta will be 23 by 12. This is not possible. Cos theta can't be greater than 1. Cos theta is less than 1 and minus 1. So there, this is the Max way of saying for whatever you are asking, for that to happen, cos theta has to be 23 by 12, but cos theta can't be greater than 1. So the answer for this thing is such vectors don't exist. So in the exam, right, there'll be an option 23 by 12 and there'll be an option none of this. Now in a flow, what will happen? You'll mark 23 by 12 and come in excitement. You need to understand cos theta is greater than 1 here. So this is the max way of saying, boss, what you're asking is not possible. Clear, everyone? Easy? Now makes sense what happened here? Now here, Firbina, I gave it in a way you can see. Let me show you the same question in another way where you can't see and tell this directly, but this will happen. Any doubts on this page? The same question is framed this way. Let's say mod A bar is 2 times mod B bar is equal to 3 times mod C bar. So values are not given, there's just some relation between them, and A plus B bar is equal to C bar. Same story, find angle between A bar and B bar. So that is one thing. Just because there is a question doesn't mean it should be right. You can also get a wrong answer for that. The wrong question is wrong. What did you get, cos theta? So this would be a better way of hiding that this is not possible, but you will know only until when you solve it. Yeah. The previous question, you can clearly see and tell, boss, there is something wrong with the question. Cos theta 2 you got? No, cos theta is not 2. Cos theta is 1. Nahi re. We have one answer so far. Ishman got it. Show you? See. The same formula repeated, we're using the same thing. So c square is a square plus b square plus 2ab cos theta. Now let's convert everything into one symbol, okay? So here see 3 times c is a. So what is 1c? A by 3. I'll convert everything into a. So it'll be a by 3 whole square. A is a square only. What is b? B is, I'm writing in terms of a, so b is a by 2. Plus 2 into a into b is a by 2. You getting what I did? I converted b in terms of a, I converted c in terms of a. Right, Samyak. There, that's your conversion there. Now I got everywhere a square gets cancelled. This guy will be a square by 9, a square by 4 plus a square cos theta. A square goes off, this will be 1 by 9 is equal to 5 by 4 plus cos theta. Therefore, we get cos theta is equal to 1 by 9 minus 5 by 4. That is minus 41 by 36. This is less than minus 1. Isn't it? This thing. So cos theta can't be less than minus 1. This is not possible. Again, same thing. Such vectors can't exist. So this thing, until you solve, you won't realize, these vectors won't be possible. Previous one was easy to see. Is this clear, everyone? Easy? Any doubts on this? So primarily in this, Shreyansh, you can argue like that also. That is also right. So in parallelogram vectors, right, primarily you have like 2 to 3 varieties. One is what? I'll give you A and B and C. I'll ask you angle between A and B. Or I'll ask you angle between B and C or A and C. That is one type of question, right? Primarily, these are the main ones. And then, yeah, this is another one. Vectors don't exist. Next thing, we have something called Lamis theorem. We're not going to use this anywhere. We have a better technique than this, resolution of vectors. But then again, better you know it because you'll see somewhere and you'll think this is something new. So what is Lamis theorem? So if 3 forces are acting on a body, are in equilibrium, then, so see, if you have a body here and there are 3 forces, F1, F2, F3. So the angle opposite to F1, let's call it alpha. The angle opposite to F2, let's call it beta. Angle opposite to F3, let's call it gamma. So what this thing says is F1 by sine of the opposite angle alpha is F2 sine of the opposite angle beta. F3 sine of the opposite angle gamma. Basically, this is same as sine rule. If you see, the parallelogram law is similar to cosine rule. Now, the reason why I don't like this, we don't use this because this is only valid for 3 forces. If you have 10 forces, I can't do this. But if you remember resolution of vectors, I can always use that. I cap, j cap, solve it. So just know this name. There's something called Lamis theorem. That's it. We're not really interested in this. We'll not be using it anywhere. Clear, everyone? Next thing. Scalar dot product. All 3 vectors must be coplanar. Obviously, right? If the vectors are not coplanar, you won't get this thing. They won't form a triangle. Acting and word in an equilibrium and in the same plane. So I'll write that also. Next thing, scalar dot product. So in vectors, right, addition subtraction is fine, but there is nothing like a direct multiplication. So, but we have something similar to that. Scalar dot product. Now remember, in the beginning I told you this chapter was actually made up. Because we are using these concepts frequently, people created this chapter. So scalar dot product is also one such thing. So this is what people observed. People observed, so listen carefully, quite a useful one. Certain scalar quantities which depend on magnitude of the vectors and cosine of the angle between them. So people noticed, there are a lot of quantities like this which depend on cosine of angle between two vectors. For example, let's say force is this thing. This is S and this is theta. Then we know the work done is given by Fs cos theta. Right? If you take something like power, it is given by Fv cos theta. Suppose if you take something like electric flux, we will see this in 12th. This depends on E into A into cos theta. E is electric field, A is area. So people noticed, there are a lot of quantities that are coming up like this. Then they said, okay, so since these kind of quantities are coming up, so let's generalize them. So they said, if you see any quantity like mod A, mod B, the two magnitudes, and cos theta, where theta is angle between them, let's write them as A bar dot B bar. You're getting it? So it is just a representation. Anytime you see a thing like this AB cos theta, you can write it as A dot B. Remember, that's how you pronounce it, A dot B. It is not A into B, right? It is not a multiplication. There's nothing like that. That means this formula here will become F bar dot S bar. This will become F bar dot V bar. This will become E bar dot A bar. That's it. Just simply keep it that way. Clear with this? So what is the physical meaning of this? Clear with this page, everyone? Let's see what is the physical meaning of this. So A bar dot B bar is given by mod A, mod B, cos theta. So basically, this thing is a scalar quantity. That's why we call it a scalar dot product. So if you do dot product of two vectors, what you get is a scalar. So what is the physical significance? Listen to this thing. Let's say if you have two vectors, A bar, and if you have a vector B bar, and let's say if you shine some light from the top, let's say this is light perpendicular to B bar. Then what you get? You will notice whatever the light falls here, you'll get the shadow of this thing. So this red line here is nothing but shadow of A bar along B bar. So there is a official name for this. The technical name for this thing is called projection. So what is the effect of A bar in the direction of B bar? So this thing is called as projection of A bar along B bar, or you can also call it as component of A bar along B bar. So most of the times, right, what happens every time, right, you'll not be so lucky to divide the components along I cap and J cap. Sometimes you want to divide the component in some other random direction, right? For example, say, imagine, let's say we have a cylinder like this. Inside we have a ball here. And let's say ball is going with a speed of 3 meters per second. And let's say this entire pipe here is being pulled up with a speed of 4 meters per second. What is the speed of the ball? The ball is going inside a pipe with 3 meters per second, and the whole pipe is going up with 4 meters per second. Now, if I ask you, what is the speed of the ball? What is the speed of the ball? If you see, the ball is going horizontally with 3, and there's also going up with 4, right? It's actually 5, isn't it? So after some time, you'll notice this thing. When the pipe has come here, the ball has reached here. So for a person seeing from the ground, he will think the ball is going this way. But tell me one thing, if I say the length of the pipe is 6 meters, in how much time will the ball come out of the pipe? Will you write 6 by 5 or will you write 6 by 3?
6 by 3, right?
6 by 3, right? Because see, you're traveling horizontally, so I want horizontal velocity. You don't take the full speed. So most of the times, right, when you see things, the full speed is actually 5, but that is useless. 3 is the component with which you're coming out. So we prefer to take components most of the times. The exact velocity need not be necessary. You're getting it? So even though the speed of the ball is 5, the time taken for the ball to come out of the pipe is 6 by 3 meters per second, where 3 is the horizontal component. So you can say 3 is the component of this velocity along the pipe. Are you getting the meaning of that? So every time when you get some velocity, you want to divide components. This will be useful. We'll see how that is done. So this is what it is. So this is a bar. This is b bar. This is theta. So if you drop the shadow of this a bar, so this shadow ka length is a cos theta, and it is pointing in which direction? It is pointing in the direction of b bar. So the vector will be b cap. So there, this is how we write it, everyone. Vector component of a bar along b bar. So you can read it like this. The length of the shadow of a bar in the direction of b bar is given by a cos theta, that is the length of the shadow, and which direction? B cap. Do you guys remember what is the meaning of unit vector? Unit vector gives you the direction. For example, if I walked 10 kilometer east, which way did I walk? East. So 1 times east. Getting it? So a cos theta gives magnitude. That is the length of the shadow. And B cap tells you in which direction is the shadow pointing. So this can be also written as, from this formula, a cos theta will be a bar dot b bar by mod b bar into B cap. This is the vector component, everyone. In case you're wondering how I got that, AB cos theta is mod A mod B cos theta. A cos theta is A bar dot B bar by mod B bar. We just shifted this thing here. You can put that down in the red box. So if I give you two vectors, and if I ask you what is the length of the shadow of one vector on another vector, this is how you find it. A cos theta is the length of the shadow, and B cap is the direction of that shadow. A cos theta can be written as this A dot B by mod B bar. I'll show you how to calculate A dot B exactly. But let's see the interpretation of it. So the scalar dot product, right, it gives you components of one vector in the direction of another vector. Clear, everyone? Again, remember, this chapter, right, is a little kind of, it's not that intuitive and all, because it's all the mathematical skills. The actual questions of this thing, right, will come in some other chapter. So here we are just learning a mathematical technique, how to solve a dot product and how to get the length of a shadow. The questions will be something else. They would look something like this. Yeah, should be somewhere here. I couldn't find it right now. It should be here, I guess. Nah, it's there somewhere. We'll see later on when it comes. Clear with this? Same thing, I can do another way. Everyone copied this in the red box? I can do the other way around. Let's say if this is A bar, this is B bar, and this is theta. Now this time, shine light this way, perpendicular to A bar. This time B ka shadow will fall on A. So this will be the length of the shadow, which is B cos theta. You're getting it? You can play the other way around also. So this is vector component. So that's the easy way to remember. When you say vector component, listen to this thing, vector component of B bar along A bar. So just try to understand the meaning of it. So you are asking what is the length of the shadow of B on A bar, which is the length of the shadow is B cos theta. In which direction? Along A bar. The direction is a cap. That's how you read it. It will be easy to understand. The length of the shadow is b cos theta along b bar, a bar. And what is b cos theta? A bar dot b bar by mod a bar by a cap. There, the reverse of that. So if you want a along b, it will be a dot b by b. This is a dot b by a. So I can find shadow of a on b or b on a. Either way it works. And both need not be same, huh? Because one shadow length is a cos theta, another shadow length is b cos theta. Did anyone receive the booklets? Not yet. I think they'll be dispatched today, I guess, or tomorrow. Copied? This is fine. Now there's one more thing. Now you said this is a bar. Great. This is b bar. This is theta. So when you drop the shadow here, this is the parallel vector. This is a perpendicular vector. So a perpendicular, this is a perpendicular component of a bar right, or perpendicular component to b bar. A parallel is component along b bar. So you can divide a vector into two perpendiculars. So I want to find that perpendicular component. How do we find that? So can I write any vector a bar as the parallel component plus the perpendicular component? So we can write the perpendicular component as a bar minus a parallel. But what is a parallel? This we already just studied, which is a cos theta b cap, which is a bar dot b bar by mod b cap. So if you substitute here, we get a perpendicular will be a bar minus a bar dot b bar by mod b bar into b cap. This is how you get a perpendicular component. Again, be careful here. How did you get a cos theta? Mod a, mod b, cos theta is a dot b. I am just worried that you might be confused here. So I'll just show you that. So a cos theta, you are replacing this with a bar dot b bar by mod b. So just try to understand what it means. Don't worry, we will do some problems on this and that will become more clear. So what you're trying to find is the length of the shadow. That is a component along the vector, but you can also get a perpendicular one. This is not a standard one. Clear, everyone? Great. So we got the meaning. It is telling you how to get the components. It's telling you how to get the length of the shadow, perpendicular and all that. How do we exactly calculate this? Can I go ahead? Any doubt so far? Sit straight, everyone. Don't put your hand on the head. Next one. So listen to this stuff. So if I do I cap dot I cap, again, remember what is the formula? A dot B is mod A mod B cos theta. What is the angle between I cap and I cap? I cap means what? X-axis. What is the angle between X-axis and X-axis? Parallel vectors, right? 0. Cos 0. So mod I cap is 1. Cos 0 is 1. So this is 1. Similarly, J cap dot J cap will be same thing. Mod J, which is 1. Mod J cap is 1. Y and Y axis parallel 1. If you do K dot K, this is also mod K cap, cos 0. This is also 1. So if you do the like vectors, you get always 1. Suppose if you do the opposite, I dot j, these are perpendicular vectors. I is x-axis, j is y-axis. So angle between them is 90. Cos 90, 0. If you do j dot k, 0. If you do k dot I, 0. So if you do like vectors I dot I, you get 1. If you do I dot j, you get 0. We have a dot b is equal to b dot a. So I dot j is equal to j dot I. It is the same thing. So these are some of the properties here. So if you have a dot b bar plus c bar, you can expand this. A bar dot b bar plus a bar dot c bar. If two vectors are perpendicular, then a dot b will be mod a mod b cos 90, which is 0. So if two vectors are perpendicular, dot product is 0. Suppose if I have a vector a bar, which is ax I cap. So listen to this thing, a y j cap and a z k cap. And if you have another vector b bar, bx I cap, by j cap, and bz k cap. And if you want to do the dot product of this, a bar dot b bar, now see how many terms are there. You have to multiply ax with bx, by, az, 3 terms, ay with bx, by, and z, 3 terms, az with bx, by, with 3 terms. Total you'll get 9 terms. Let me show it to you. It is boring, but yeah. So if you do ax in this thing, you will get ax, bx, you will get I dot I. Then if I do these two terms, ax, by, I dot j, that would be ax, bz, I dot k. You can clearly see the other vectors are becoming 0. This guy will be ay, bx, j dot I plus ay, by, j dot j, ay, bz, j dot k, az, bx, k dot I, az, by, k dot j, az, bz, k dot k. You can clearly see here, this term is gone 0, 0, 0, 0, 0, 0. So you're only left with I dot I becomes 1. Ax, bx, ay, by. So dot product is actually easy. You just multiply the I components, j components, k components, and finish it off. So a dot b is this. If someone tells you to find what is a bar dot b bar, simply multiply the I components, j components, and k components. Have a look at this page. This is how you find dot product between two vectors. So what is the primary use if you ask me, right? If someone gives you two vectors and asks you to find angle between them, dot product is the best. So that is one thing. It's pretty useful to find angle between two vectors. Because think about it, in parallelogram law, I needed c square is equal to a square plus b square 2ab cos theta. I needed three vectors ka magnitudes. But this guy will give you angle with only two vectors. So parallelogram law is useful if you have three magnitudes. Dot product is useful when you have two vectors, I cap, k cap, and k cap. So this is important. The one in the red box, remaining are the same things. It's fine. Clear, everyone? Everyone got how did I get a dot b? So if you give two vectors a bar dot b bar, which is mod a, mod b, cos theta. So the angle is given by cos theta, which is a bar dot b bar by mod a mod b. Just now we saw what is a dot b bar? Ax bx, ay by, az bz by root over mod a bar will be I hope you remember magnitude of a vector. Ax square, ay square, az square. The coefficient of I cap, j cap, and k cap. Bx square, by square, and bz square. This is how we find the angle between two vectors. Is this clear, everyone? I'll be sending you a sheet on vectors today. Next class, we'll wrap up the chapter. And then we are on a break for some time, for a week. Once we are back, we'll start off with calculus. Clear with this? Let's see some questions on this. Let's start off a little easy. So I have two vectors, a bar, which is 3 I cap minus j cap plus 2 k cap. B bar is I cap plus j cap minus k cap. Find a bar dot b bar. Find angle between a bar and b bar. And find vector component of a bar along b bar. Find vector component of b bar along a bar. That basically this literally covers everything that we did. Let's start from the top. A dot b, angle, everything will fall in place. Give it a try. I'll show you that. You're getting 0 again. Did I give them perpendicular? Yeah, I did a mistake. Make it plus here. Accidentally I made it 0. Then you know what will be the answer for everything? 0, 90, 0, 0. Done. Life would have been so easy. I changed the question. Please change the numbers. I plus j plus k. Now get it. Find a dot b, find the angle between a and b, find the component of a bar along b bar along a bar. Everyone should try. It's okay if you don't get it, but try. Let's see the first part. A bar dot b bar. What is that? Ax, bx, ay, by. Az, Bz. So multiply the I components ka coefficients, J ka coefficients, K ka coefficients. That will be 3 into 1 minus 1 into 1, 2 into 1, that is 4. Next thing, you want to find the angle between the vectors? Cos theta is A bar dot B bar by mod A bar mod B bar. That is the formula, right? A dot B is mod A mod B cos theta. A dot B is 4. Just now we proved. What is mod A bar? Root over. How to find magnitude of a vector? Coefficient squares. So take a vector and get the coefficient ka squares. Root over 3 square, 1 square, 2 square. Root over 1 square, 1 square, and 1 square. That will be root over 4 by, that will be 9 plus 10 root 14 into root 3. That is 4 by root 42. You can leave the answer like that. That is the angle between them. Is that it making sense, everyone? Get the third part and fourth part. Find the vector component of A bar along B bar. We have one answer from over here. Let's see. Others? That might be right over here. Let's see. What is the third one? I'll just write the formula there. Vector component of A bar along B bar. Just ask yourself, forget about the formula. What am I saying? Vector component of A bar along B bar. So I'm asking the shadow of A bar. What is the shadow of A bar? A cos theta. In which direction? B bar ka direction, B cap. Isn't that the meaning of it? Now write down, what is A cos theta? A cos theta is nothing but A dot B by mod B and into B cap. I already know this thing. What is A dot B? A dot B is 4. What is mod B? Mod B is this guy, root 3. What is B cap? B cap is nothing but get the vector B bar and divide by its own magnitude. And B bar is how much? I plus J plus K. So I plus J plus K by magnitude root 3. Substitute here. I plus J plus K by root 3. That's your answer. 4 by 3, I plus J plus K. So this is the length of the shadow or the shadow ka thing of A bar and B bar. Same thing, vector component of B bar along A bar. Again, understand the meaning of this. I want B bar ka shadow. Shadow ka length is B cos theta. It will be the adjacent side in the direction of A cap. So this is again A dot B by mod A bar. Same story. This is 4 and mod A bar is root 14. And A cap will be this vector 3i minus j plus 2k and divided by its magnitude, which is root 14. That will be 2 by 7. 3i minus j plus 2k. Is this clear, everyone? Any doubts on what we did? So whenever you hear the word vector component of A bar along B bar, so read it like this. Component of A bar, matlab A bar ka shadow, which is A cos theta, along B bar into B cap. And then you can represent A cos theta like this, so it will be done. All clear with this? Or actually A cos theta you could write like this also, na? A ka magnitude I know, cos theta I know. Just multiply into cos theta. That also works. Any doubts on this? Quite an important one. You should definitely be comfortable with scalar dot product. Quite a useful technique, comes a lot. You start encountering this from scalars, vectors only. Calculus only, you'll start encountering this stuff. Let's see one more like this. Let's get used to this. Let's say A bar is 2i plus j plus k, and B bar is, let's say, I minus 2j plus 3k. Yeah. Find angle between A bar and B bar. This is the standard one. Find angle between A plus 2B bar and 2A minus B bar. Find a component, vector component of A bar along B bar. Find a component perpendicular component of A bar to B bar. There. So I brought that perpendicular thing also. Let's get this. The first one is easy, standard one. Let's get that. Three root, yeah, right over here. Right, Samyak. First one is fine. Right, Siddesh. Now, does you got an answer? You should type in the chat box to the co-host. 3 degrees. How did you get 3 degrees, right? Such a good number. Right, Trishi. Right, Devanshi. Right, Sam. Yeah, most of you got the first part. Second one. How did you guys get 3? It is 3 by root 84, right? Let's see the first one. First one was easy. So A dot B is mod A, mod B, cos theta. This is the formula. What is A dot B? Multiply I ka coefficients, J ka coefficients, K ka coefficients. That's how we find A dot B, which is 2 into 1, 1 into minus 2, 1 into 3. Mod A bar is root over 2 square, 1 square, 1 square. Mod B bar is 1 square, 2 square, 3 square, cos theta. This will be 3. This will be 4. That will be 14. So yeah, you get cos theta will be 3 by root 84. Yeah, you can take out 4 common, but same thing. That's your answer. What about the second one? How will you find angle between A plus 2B and 2A minus B? One way to do, right, is brute force. Just add A plus 2B, get a vector. Add 2A minus B, get a vector. That is one way to do, but there's a better way. See, you want angle between A plus 2B and 2A minus B, right? So I can do this directly. I'll do it in the next page. One is the brute force. What is a plus 2b? A plus 2b will be how much? 2 plus 2, 4i. I plus minus 2 minus 3j. B will be 7k. 2a minus b will be how much? 2 to 4 minus 1, 3i. 2 minus of minus 2 plus 4j. Tell me if I did something wrong here. 2 minus 3 minus k cap. Right? I got these two vectors. I can find the angle from there, and that is easy. So these are the two vectors. Let's call them c bar. Let's call them d bar. So I have created new vectors. So angle between c bar and d bar is c bar dot d bar mod c bar mod d bar. Let the angle be some theta or some alpha, doesn't matter. Is this clear, everyone? So just add them up, you get new vectors, and now find the angle between them. So this guy will be how much? Again, multiply the coefficients. Are these vectors right? Check. Or did I goof up somewhere? Anyone else got the same vectors? I'm getting a feeling I messed up any one of them. Right? Got the same? Then great. Then what is the dot product? Multiply the coefficients. 4 into 3, 12. Minus 3 into minus 4, minus 12. 7 into that, minus 7. Mod c bar will be root over 4 square, 3 square, 7 square. Numbers are big. This is 3 square, 4 square, 1 square cos alpha. So cos alpha will be minus 7 by root over 25 plus 49, root 74 by root 26. Wow. Check. Quite a bad number, but yeah, that's how you do this thing. This is one way. Another way to do this thing, same idea, but I think that will become more lengthy actually. I thought we can do like this. A plus 2b bar, we can do directly to dot product of these two. But then we will get stuck with a plus 2b and 2a minus b. That will be a mess. Okay, let's not do that. That will actually be more complex. Isn't 2a minus b 3i plus 5k? Let's see, what is 2a? 4 minus b, that is 3. Then this is a 2 minus of minus 2, that is 4. So there is already a minus here and there is one more minus, right? It adds up. Right? Yeah. Question is still not over, everyone. What about this third part and the fourth part? Find the vector component of a bar along b bar. That is okay. That's the standard question. Find the perpendicular component of a bar along b bar. Remember, when I say vector component, I want I cap, j cap, k cap. I don't want magnitude. Get this. I'll give you a minute or two. Especially if it was an exam, right? I'll ask you the fourth question because third is the standard one. But you need the third one to get the fourth one. You can do that way or you can do it independently. Try. I'll give you 2 minutes. So what is the vector component of a bar along b bar? Again, same story. You're asking component of A bar. So I want A ka shadow, which is A cos theta. In which direction? B cap ka direction. So A cos theta can be written as A dot B bar by mod B bar into B cap. So what is A dot B? 2 minus 2, that is 3. And what is mod B bar? Root over 1 square, 2 square plus 3 square. And what is B cap? B cap is take the B ka vector I minus 2j plus 3k and divide by its own magnitude. This will be 3 by 14. I cap minus 2j cap plus 3k cap. Clear? Now how to get the perpendicular vector? One, if you can remember this formula, this guy, if you can remember this, you'll get it. But this is too big and too confusing to remember. But try to use the logic here. Listen to the logic. Any vector A bar can be split into two parts. The A parallel component, that is your shadow, and the A perpendicular component. Agreed? So I can write any vector A bar as A parallel plus A perpendicular. So if you remember this thing, you're done actually. This is only the A parallel component, isn't it? So A perpendicular is nothing but A bar minus A parallel. What is A bar? 2y minus plus j plus k minus what is A parallel? 3 by 14 I minus 2j plus 3k. Done. No need to remember any formulas. You know already how to find the parallel component. Find it and subtract it from the main vector. You'll get the perpendicular. Is the logic making sense? Instead of using all that complex formulas, understand the crux of it. How many formulas will you remember? And how much is this if you simplify? 14 to 28 minus 3, 25 I cap. 14 plus 6, 20 j cap. 14 minus 9 plus 5k cap by 14. That's your answer. Is this clear, everyone? You should definitely try this again tomorrow. Tomorrow take a rough paper and try to solve each and every question again. हाँ आर्या बोलो ना.
Sir, can we
Hmm.
solve it like we will cos theta and then we will find sine through that and then just multiply?
नहीं प्रॉब्लम क्या होगा. चलो a sin theta you're saying ना. A sin theta will give you the
Yes,
magnitude, but how will you get the direction?
sir, but okay,
B cap नहीं है ना direction. A parallel का
yeah,
direction है, it is along B bar. That was easy to say. A perpendicular is nothing. It's not along A bar. It is not along B bar. So I can give you the magnitude, but I can't get the direction.
all right.
That is a problem with the perpendicular thing. So the perpendicular one is a very good question. Not difficult to solve. You know how to solve the parallel one. Subtract that from the main vector. Whatever is left is the perpendicular one. Is that making sense, everyone? Any doubt so far? Take a break. Come back by 9:45. Any doubt so far? Please ask me. Chalo, come back by 9:45 then. Chalo, let's start off. So let's say we have a bar, which is xi cap plus 3j cap minus 2k cap. And b bar is let's say 3xi cap plus 4j cap plus xk cap. Find x if a is perpendicular to b. So in physics, remember this thing, 11th and 12th, you hear the word two vectors are perpendicular. The first thing they're saying is use dot product. Meaning, I'll show you see how they'll frame these things. This you'll encounter from kinematics only. Look at this question. So we have a building here. Someone projected a particle with speed u on the left-hand side. Someone else threw another particle to you with on the left-hand side. So this guy is going this way and this guy is going this way. And look at the question here. Find the time when the velocity vectors are perpendicular. Find the time when displacement vectors are perpendicular. So you'll hear words like this, vectors are perpendicular. And see what we did. So we found the vectors, VA bar, VB bar, then we did dot product. We found the displacement vectors, I cap, J cap, dot product. Questions will come like this. No one will ask you what is dot product directly. You're getting it? Like I said, this thing is like, think of like this. When you're cooking food, dot product is like curry patta. No one makes the curry out of curry patta, right? You add it in some other dish. So dot product is part of a bigger problem. So think of that thing. So get this. This is an easy one. Okay, we have one answer. Oh, we have got minus 12. Anyone else got something? Just get the dot product and do equal to 0. Yeah, minus 12. Chalo, fast. I'll give another 10, 15, 20 seconds. If two vectors are perpendicular, the dot product is 0. So a bar dot b bar must be 0. So a dot b bar will be 3x square plus 12 minus 2x is equal to 0. You guys didn't get a quadratic? So this 3x square minus 2x plus 12 is equal to 0. I think we might get imaginary roots. X is equal to 2 plus or minus root over b square. These are imaginary roots, right? How do you guys get x ka value? Roots don't exist. There is no value of x for which these two vectors will be perpendicular. So that will be 4 minus 4 into 12. That is 48 by 6. Roots are imaginary. A and B can never be perpendicular. A bar and B bar can never be perpendicular. That is the meaning of it. Clear, everyone? How did you guys get minus 12? You forgot the 3x square, yeah? I think you wrote that as 3x.
I got 3 I cap. I didn't see.
I didn't say the x.
Sir,
Huh.
shouldn't it be 4 minus 144?
4 minus 4 AC है ना? I didn't see that. I think 144. ठीक है, फिर भी imaginary. Others, do keep your cams on. Clear, everyone? Next thing. So work done is given by force dot displacement. Okay. And here we came to know the particle is going on a line. So we have a line here, which is y is equal to, let's say 3y minus 2x plus 1 is equal to 0. A particle moves along the line 3y minus 2x plus 1 is equal to 0. Under the action of the force F bar, which is equal to 5i plus some p into j. P is some number. Find p if work done is 0. So this is another way of asking vectors are perpendicular. They won't give it in a straightforward way. So look at the question. We have a particle going along this green line. So someone is applying a force such that the work done is 0. And work done is given as force dot product S bar. So try to go in the reverse. Work done is 0. That means F bar and S bar are perpendicular. So that person is indirectly saying this force vector F bar is perpendicular to this green line. Then what is this value P here? Is the question clear how to interpret the whole thing? They won't simply say find, two vectors are perpendicular, find dot product. That is an easy way of asking. They will play like this. They will say work is there, line is there, and all that stuff. Try. We have one answer. Not sure whether it is right, but let's see. Try others. I'll give you a minute or so. But someone didn't get the question. Please ask me. How do we start? I'll give you a hint. See, in school you studied the statement. If two lines are perpendicular, then the product of the slopes is
-1.
-1. Did you guys study something like this in school? So can you use that and figure it out? There is another. If I give you a line, I can't use it as a vector. I can get a vector here, but I can use product of the slopes is -1. Now think. I'll give you another 30-40 seconds. Let's see. So this is how you start the whole argument with. You said work done is F bar dot S bar. And you're saying since work is 0, this implies the force must have been perpendicular to the displacement vector. And if two lines are perpendicular or two vectors are perpendicular, the product of the slopes is -1. Now this you should know from school. Perfect. So the line equation was 3y minus 2x plus 1 is equal to 0. So this will be y is equal to 2 by 3x minus 1 by 3. So this slope m1 is 2 by 3. How do you get the slope of a vector? What? Now you said this force is 5i plus pj. So it's easy. Just write it like this. So 5 horizontally, p vertically. So indirectly I'm asking to find tan theta, isn't it? This is the slope. The slope of a vector is nothing but tan theta, which is y coordinate by x coordinate, which is p by 5. So you're saying the product of these two slopes, I'll just call it m2, is -1. So m1, m2 is -1. So this is 2 by 3 into p by 5 is equal to -1. So p is equal to -15 by 2. Is this making sense, everyone? So for a vector, the slope is simply y by x coordinate. For a line, the slope is y is equal to mx plus cm. And if you're saying these two are perpendicular, the product of the slopes is -1. Do have a look at the steps. Any doubts on this? Clear, everyone? Next one. Clear, na, Advait? Sudiksha? Utsa? Clear with this? Srihari? Shaunak? Yashvi? Ananya? Next one. So we got the cube here. X-axis, y-axis, z-axis. So this is your origin 0, 0, 0. This is O. This is point A. This is point B, and this is point C. Yeah. Find angle between OA bar and OB bar. Find angle between OA bar and BC bar. Let's get this thing. Wait, I'll do one thing. Yeah, this is fine. This is fine. Get it. And if you look at these two lines, right? OA bar and this thing, these are called body diagonals. Remember, there are face diagonals. So if you look at this thing, this is the face. If you draw this line, this is the face diagonal. If you draw from this corner to this corner, this is the body diagonal. And it is not 90. Let's try.
So the side,
It doesn't matter, but take side A if you want. It's a cube, so the angles won't change because of the length of the sides. माइनस आया क्या? No, you will get minus maybe. I think there's an obtuse here. That is okay. 1 by 3 is right. Plus or minus, it will actually depend on the orientation. If you have taken OA and CB, you would have got a plus. That is okay. How to do this kind of questions? Get the coordinates. And I already taught you how to find the coordinates in a cube. We have done this before. So if you travel along the x-axis, the coordinates will be, so if you travel along x, only the a will change, x will change. A comma 0 comma 0. From here, if you go straight up, you're going along y-axis, so only the y coordinate will change. That will be a comma 0. From here, if you go this way, you're traveling along z-axis, so this coordinate will be a comma a. Here, if you travel from O to C, you're traveling only in the z direction, 0 comma 0 comma a. Did everyone get the coordinates, everyone? So if you travel along x, x coordinate changes. If you go along y, y will change. If you go along z, z will change, and so on. So you want OA bar. So OA bar, you're going from O to A. So A is final, O is initial. This is also A. So that will be AI cap, AJ cap, AK cap. Then if you go from B to C, you're going from B to C. So C is final, C minus A, minus AI cap, minus AJ cap, plus AK cap. You're done. You want angle between these two vectors? OA bar dot BC bar. The moment you say angle means dot product only. Mod A bar, mod BC bar, cos theta. Substitute. What is this thing? This will be minus a square plus a square. This will be a root 3. This will be a root 3 cos theta. Yeah, cos theta is minus 1 by 3. Clear, everyone? Same stuff. What we're doing dot product, but this time you also have to find the coordinates yourself. And Arya, you know why they're not 90 degrees? Think about this. This center one, if I make this thing, is this a rectangle or a
It's a
square?
rectangle. It's a rectangle. A
So
root
they
3
won't be
and
perpendicular.
that's we can actually find them in other way also, right? By using
Like,
trigonometry in the
हाँ
rectangle.
वो कर सकते हो. वो किया ना वो क्वेश्चन याद है ये strings वाला.
Yeah.
You can do that stuff, but yeah. Clear with this, everyone?
Yeah, I got
Any doubts
2
on this?
tan arctan root 2.
You can convert this. No. Remember last class when we did a question? If you have three vectors, let's say mod A bar is equal to 2, mod B bar, let's say I'm making it even more worse, 3. This I give you in the sheet also. Mod C bar is equal to 4. If I angle between any two vectors is 60 degrees, then find mod of A bar plus B bar plus C bar. Now, last time that way I showed you was pure geometry, but using dot product, you will get it in a more convenient way. How do we use dot product to get this? Try. Think. How do you do this thing? Yeah, see how to do this thing. So A bar plus B bar plus C bar dot, if I do this thing, A bar plus B bar dot C bar, right? So this will become what? So if you multiply this, you'll get A dot A, B dot B, C dot C. You'll get 2 times A dot B. Remember, this is not A into B, and this is A dot B, 2 times B dot C plus 2 times C dot A. So the left-hand side, this is, if you do A bar dot A bar, you'll get mod A plus B plus C ka square. A dot A is A square plus B square plus C square plus 2AB cos 60, that is the angle between them. 2BC cos 60, 2CA cos 60. Meaning the thing with this, right? You just lose all the information. I don't care what is the shape. I don't care how is it looking. Like you don't need anything. You just put the numbers, you'll get an answer. What is A square? 4. This is 9. This is 16. This is 2 into 2 into 12. So 12 into half. So that is 6. 2 into 3. So that is 4. 3 is 12 again. C into A is 8. How much is this? 26, 30. I messed up something, I guess. 2AB. This is 3, no? No. A into B, that is 6 only. B into C is 12. C into A is this. Okay, how much is this? 20, 26, 30, 30 and 16, 46, 46 plus 9, yeah, 55. This is mod of A plus B plus C ka square. Therefore, mod of A plus B plus C is root 55. Is that clear, everyone? Any doubts on this? And the best part about this thing, the angle need not be 60. I can say the angle between A and B is 60, angle between B and C is 45, angle between C and A is some 30. It still works. Because every time there's no guarantee, this will be a beautiful tetrahedron, right? So that 60, 60, 60 was a very special case of getting a tetrahedron. Is this clear, everyone? So that you can just square that and finish it off. So last time it was so complex, isn't it? Drop a perpendicular, find the angle, then take the component and all this stuff. First of all, you should know it's a tetrahedron, and then you should do all this stuff. Saves you time. You see the answer pretty fast, but you lose all the understanding and information. Clear with this? Next one. Mod A bar is equal to 2. Mod B bar is equal to 1. And A bar is perpendicular to B bar. Find angle between A bar plus 2B bar and A bar minus B bar. This is a good one, right? In entire so far dot product, right? These are some tough questions. 27. Let's get this. No, I didn't give you I cap, J cap, K cap, nothing I gave you. I just gave you the magnitudes and angle between them. And I wanted to find the angle between this vector and this vector. Think for 2 minutes. How will you approach this? Then I'll show you one and I'll give you one more like this. 0. 1 by root 10. Chalo, listen, I'll show you one. Listen carefully. So you're asking for a plus b and a minus b. So I can treat this a plus b, some like a new vector. Let's call it c bar. Let's call it d bar. So indirectly you're asking me find the angle between c bar and d bar. So c bar dot d bar is mod c bar mod d bar, and the angle between them, let it be alpha. So alpha is angle between c bar and d bar. So this will be a plus 2b dot a minus b bar. This will be mod of a plus 2b. This will be mod of a bar minus b bar cos alpha. So on the LHS side, it's a dot product. So a dot a minus a dot b. Remember, that's a dot. 2b dot a minus 2b dot b. What is mod a plus 2b? This is parallelogram law of vectors, isn't it? What is mod of a plus b? Root over a square plus b square plus 2ab cos theta. What is mod of a plus 2b? A square plus 2b whole square plus 2 into a into 2b into the angle between them is cos 90. Root over what is a minus b? A square plus b square minus 2ab, angle between them cos 90, cos alpha. Since the vectors are perpendicular, a dot b is 0, a dot b is 0. Why? A is perpendicular to b. What is a dot a? A square minus 2b square. This will be root over, this guy is 0, this guy is gone. A square plus 4b square, a square plus b square. There's nothing there, it's all just number substitute, they will get the answer. A square is 4, this is minus 2, this is root over a square, 4 plus 4, this is 4 plus 1. So we get cos alpha will be 2 by, that is root 8, root 5. Root 8 is 2 root 2, 1 by root 10. This is how you approach this problem.
Sir, how is a vector dot a vector a square?
See, a bar dot a bar is what? Mod a, mod a. What is the angle between a bar and a bar? 0, which is a square. Is that clear? I'll just put that down in this property. See, you can remember this. Suppose if you have a bar dot a bar, this is nothing but mod a bar, mod a bar. So angle between yourself is 0. This is a square. Clear? So keep that in mind. Did you get, how did I get this thing? Have a look at this. I'll give you one more like this. So basically the LHS consists of dot product. The RHS consists of parallelogram law vectors. This is parallelogram law vectors. Mod of a plus b is root over a square plus b square plus 2ab cos theta. That's what makes this question good. You are using two concepts at the same time. Everyone clear with the
I
steps?
did a different method.
What did you do?
So can we like find it using making a triangle and then using cosine?
For triangle, where is the third side?
Sir, we can take both are like in the
No, because
same
it is
plane.
perpendicular, you are saying that. Next, you won't be able to do the next one like that. But still didn't get an answer, right? You must have goofed up somewhere. Check it out. See, if you got an answer, send me the working. So mod a bar is 1, mod b bar is 1. I'll keep the thing same. Angle between a bar and b bar is 60 degrees. Pi by 3. There. Now a dot b won't be 0. So find angle between 2a plus b bar and a bar minus 2b bar. Get this. Same question, I just changed the numbers a bit. Remember the process, you can assume that is c bar d bar, do this thing. Now try. I'll give you 2 minutes. The idea is exactly the same. How do we do this? Try. Everyone should try, calculate. It is a little working. Let's see. Any answer? 0. That was surprising. 0 is for the previous one. Anyways, let's see. So let's call this thing C bar. Let's call this thing D bar. So I'm finding the angle between these two. So C bar dot D bar is mod C bar, mod D bar, cos alpha. Same story. 2A bar plus B bar dot A bar minus 2B bar mod 2A bar plus B bar mod A bar minus 2B bar cos alpha. Cross multiply 2A dot A, that will be 2A dot A, then 4A dot B. Be careful, that is A dot B, it is not AB, plus B dot A minus 2B dot B. This is root over 4A square plus B square plus 2 into 2A into B into, check your calculations where it went from. This is cos 60 root over A square plus 4B square minus 2 into 2B into A into 2B into cos 60 into cos alpha. A dot B is how much? So this is 2A square. That is, I'll write it down. 2A square minus 3. A dot B is minus 3AB cos 60 minus 2B square. This guy on the right hand side will be how much? 4A square. That is 4. Calculations are bad. 16 tha ye. 16 plus 1 plus 2 to 4. This is 4 by root over 4 plus 4 minus 4 cos alpha. 2A square is 8 minus 3 minus 3 minus 2 root 21 root 4. Oof, 8 minus 3, 5 minus 2, 3. Cos alpha is 3 by 2 root 21. Did I mess up somewhere? There's nothing there. Once you got this equation, right, brute force it is just putting the numbers. See, I must have messed up. You must have messed up. See where it went wrong. If I did something wrong here, let me know which step. If you're confused, please ask me. The previous one was life was easy because cos 90 became 0 here. Cos 60 we have to include everywhere. Yeah. Be careful with the calculation. So these are one of the tough ones that you can ask. Because you have two concepts. One is a dot product and one is a parallelogram law of vectors. Any doubts on this? All clear with the steps? Trishi, Yashvi, got this? Tanishka, clear? Ananya, Ishman, Devanshi. Great. Next thing. Now this can be asked as a question. Can also be done as a topic. So let me just show you that. So I'll just teach it as a concept. This will again come in ray optics, a different chapter. The relation between incident, reflected, rays, and normal vector. So let's say we got a mirror. This to be studied in school. That angle of incidence is equal to angle of reflection and all that stuff. But what if they ask you in vectors? So let's say this is your normal vector. N cap is a unit normal vector. So that is a normal perpendicular to the mirror. This is your, let's call it capital I cap. This is a incident unit vector. This is how they'll ask you in advance. And after bouncing here, you will get a, let's call it R cap. This is a reflected ray unit vector. Then they'll ask you, find the relation between them. So normally, angle of that is equal to this and everything. But if they ask you in terms of the vectors, this is what we do. So listen, I'll show you how to get this done. So first thing, let's put that angles here. So this is your N cap. So listen careful, not a big derivation. So this I cap which is there, if I extend the vector, I'll push it forward. This will become I cap. Let this angle be theta. This angle also be theta. Okay. And this vector will be R cap. Now when you say unit vector, what is the magnitude? This magnitude is 1. This magnitude is 1. If this angle is theta, this angle is 90 minus theta, and this angle is 90 minus theta. That means from here to here, this will be an isosceles triangle. If that is 1, this side will be 1 sine 90 minus theta, which is the opposite side, which is 1 cos theta. And this will be 1 cos theta. So look at those vectors here. So we have, this is R cap. We have, this is I cap. And we have this black line here. In this thing, the magnitude is 2 cos theta. Can you tell me which direction is this? The black line? N cap, right?
Cap.
Isn't this parallel to this vector? The black line and the green line are parallel. So the length of the black line is 2 cos theta and the direction is n cap. Now look at this thing. From triangle law of vectors, if you go from this and this, so I cap plus 2 cos theta n cap must be r cap. If you join two vectors, tail head to tail, the resultant vector is from the remaining tail to the remaining head. So if you go along this way, I cap, and if you go upward, I will go r cap, isn't it? So that's your triangle law. Great. So look at this thing theta. So if this is n cap, right? And if this is I cap, now be careful, the angle between the vectors is 180 minus theta. So I cap dot n cap will be mod I cap mod n cap, the angle between them cos 180 minus theta. So this will be I cap dot n cap. Remember, mod I cap is 1, n cap is 1, cos 180 minus theta is cos theta minus cos theta. Therefore, see, so we got cos theta is equal to minus I cap dot n cap. So this result can be written as, so take this cos theta and dump it in this. So this result will become r cap is I cap plus 2 cos theta will be minus 2 times I cap dot n cap into n cap. So there, this would be the answer for this question. So this vector r cap is given by I cap minus 2 times I cap dot n cap into n cap. This is the relation between the reflected ray, incident ray, and the normal vector. This is how we'll get a question in advance. So they will combine this and see how many things that I used. I used dot product, I used a triangle law, I used vector components, then I mixed up with ray optics reflection. But did you see what we did? Again, I'll explain everything in briefly since. So this was n cap, this was r cap, this was I cap. So I pushed this I cap forward tail to tail. Then I found this length. How did I get this? This is 1. This is 90 minus theta. This is theta. So this is 1 cos theta. This is 1 cos theta. So this vertical length is 2 cos theta. And it is pointing upward to n cap. So I got one vector here, I cap. Then I got a vector upward, 2 cos theta n cap. And this became r cap. So from triangle of vectors, r cap is nothing but I cap plus 2 cos theta n cap. Now I know this angle is theta, but be careful there. This is joining head to tail. So this is not angle between vectors. Angle between vectors will come when you join them tail to tail. So this angle is 180 minus theta. If I do dot product here, I cap dot n cap, mod I cap is 1, mod n cap is 1. That will be cos 180 minus theta. So this was actually minus cos theta is I cap dot n cap. I took cos theta and dumped it here. Is that making sense? You should definitely go through this thing. So, exam they'll ask you questions like this. So I cap is I minus j plus k by root 3. And they'll say n cap is 2i minus j by root 5. Find r cap. You can put the things here and you'll get r cap. Is the proof clear, everyone? I know this thing is little there, but definitely go through this once. You're still confused, let me know. And don't worry about this thing. This will come again in a chapter called ray optics, and I'll teach you again. So right now it might feel overwhelming, but when in that chapter you'll feel like, okay, it's fine.
Sir,
Oh yeah.
this is only true for like when incident ray, normal and reflected ray are unit vectors.
कर सकते हैं ना, that is there ना. If I give you a vector, make it a unit vector. That too you can handle, right? Suppose if you give I bar, I plus j plus k, make it a unit vector. that can be always converted, right? You can always make a vector into unit vector. Yeah, but these all are unit vectors. Because see, agar unit vector nahi hoga na, this will not be 1 and 1 na. I won't get this a good number. That way. Clear with this, everyone? So that is a bit about scalar dot product. So next class when we catch up, maybe we'll do 1 or 2 more problems on this, and then we'll do something called vector cross product. Right? That is a little easier than this. But there is a last concept in vectors. So next class, mostly we will try to wrap up with that. Right? And then we are on a break for a week or so. And then after that, once we're back, we will start off with calculus. And after that, you're back, you'll also start having, tests also every week. And materials have been dispatched. I